Great, we are live. So welcome everyone. This is March 30th, 2022. I'm Jason Ross, and this is the seventh in an 8-week series of classes the sixth in a series of classes as an introduction to Lyndon LaRouche. Tonight's speakers are Rachel Brown and Bill Ferguson. The topic is Vernadsky and the Noosphere, and we're going to be delving into a great thinker, Vladimir Vernadsky, his relationship to the work, economic, scientific, cultural work of Lyndon LaRouche, and what this has to do with how we move forward in the world right now. Rather than give any more introduction, I will just turn it right over to Rachel. So take it away, Rachel. Welcome.
Great, thank you. Actually, I'll just start with one idea that Mr. LaRouche put out in Earth's Next 50 Years, a book he wrote in, I believe, 2004. Someone could correct me. But he talked about the need for a coming Eurasian world. And one of the personalities he said was needed for that was Vernadsky, that the ideas of Vernadsky would be crucial in creating a global culture. So I think you might get a sense of that through what we discussed today, of why that might be. He was Russian and Ukrainian. He had family from both places. He is today well known in Russia and well respected in Russia. And that would be an excellent component of this Russian scientific tradition to bring into play today as part of the global scientific discussion, is the ideas of Vernadsky and LaRouche, of course. But I would actually like to start with a little bit of what Mr. LaRouche said about the method of Vernadsky. And I am going to have some quotes that I will share with you. So let me get that on the screen. Oh, one participant can share. I think possibly someone is already sharing. Oh, no, sorry. Maybe that's, let's see. Here we go. One second, let me just get play here. Sorry, it's not letting me. Okay. All right. I don't have a particular quote from LaRouche there, but I will read it to you. So he says that Vernadsky is in the tradition of the constructive geometric philosophy of going back to the ancient Greeks. He says the problem is that many students of ancient Greek don't understand Plato. He says the problem of some of these students, such failed former students of classroom Greek and of many other students still today, has been their disposition to look up definitions in dictionaries or by quoting so-called authorities, rather than actually experiencing the relevant conception by replicating the original author's presentation of the process of generating the relevant discovery, as Vernadsky himself illustrated this method for acquiring knowledge of fundamental physical principles in the 1935 writing to which I refer here. It says, indeed, most of the crucial conceptions of valid science in globally extended European civilization today are to be traced from their implied origin in the pre-Aristotelian classical Greek, as from Thales and the Pythagoreans through the works of Plato. The conceptions of biosphere and noosphere developed by academician Vernadsky are a case in point. Now that's kind of surprising, being that Vernadsky was in the 1900s and seems very, very far from ancient Greece, but there's a question of method, which LaRouche pointed to, that Vernadsky was bringing out. For example, what is this question of spherics? So now you can see this slide I have on the screen, which is a general symbol of the night sky as depicted spherically, and the different orbits with the Earth in the center and stars, sun, planets going around. And this was sort of the first approach to the physical universe. One of the first sciences was astronomy, and looking at how motions occurred on the celestial sphere. That did not remain simply in the realm of astronomy. Let's see if I can. I can't go to the next slide. 1 second. Yeah, I lost my cursor. Let me go escape. Okay. Sorry, I just can't really seem to escape out of the screen. I don't know if Dave has any advice.
May I suggest that you hold the control key and push left and right? If you have something that's full screen, it may be causing an issue there. You're on Mac, right?
Yeah, not working. Can't do escape.
I turned your screen sharing off, if that helps.
Okay, yeah, it does. I can do stuff now. All right, let's see if I can go back. Try it again. I might have had the wrong one for some reason. Just go with this one, see if that's better. Okay, should I just leave it like this? Can you see it okay? This might. Is the visual okay like this?
I can read it. If I was on a phone, I probably couldn't, but if it works this way, maybe it's the safest way to do it.
Okay. All right, so that's that. Astronomical sphere. Another example of the constructive spherical method would be the 5 Platonic solids, of which you can only construct 5, and which tells you also something about the shape, the nature of the space that you're in, and which is only known through physical construction. Okay, yeah, let's go with it. So Vernadsky talks about 3 envelopes of he constructs, in a sense, 3 envelopes: the lithosphere, the biosphere, and the noosphere, each being a sort of a domain of action, just as we were looking at spherical action, and in the previous examples. Now we're going to look at action of a different sense. And he talks about the problem with modern, at his time, and biologists, is that they try to look simply at the morphology of organisms, and they don't look at what life does. So he takes a completely different approach, and he says life manifests itself in the Earth's crust in a way that is different from the phenomena studied by biologists. Here we notice 2 new features of its structure. We see that life acts only by means of the energy, quantity, and composition of the matter inherent to it. Secondly, we see that individual organisms move to the background in regard to the greatness of the observed phenomena. We notice only the general total effects of their activity. So he's looking not at the individual organisms, but at the activity of what he calls living matter. And he gives a couple different criteria that he's going to look at with what he mentioned here: energy, the composition of the matter. He has a new way of examining life. Yeah, we're going to look at what those are. So he says life is a more or less fast, more or less complicated whirlpool, which always captures molecules possessing certain qualities and which has a constant direction, but it is always penetrated by and always deserted by individual molecules. So the form of a living body is more significant for it than its substance. As long as this motion exists, the body within which it occurs is alive, it lives. As soon as the motion comes to a complete standstill, it dies. Here's another example of adding to that idea. When an element enters an organism, it passes through a long series of states, forming parts of many compounds before it becomes lost to the organism. In addition, the organism introduces into its system only the required quantities of these elements, avoiding any excesses. It makes choices, seizing some and leaving others, always in a definite proportion. Yeah, so that being the idea that an organism, if you look at it as a whirlpool, it's taking in material and it's letting out material through respiration, through feeding, through decomposition of its body. That's where we have oil deposits, iron deposits are, the accumulation of living bodies that leave their material bodies and substances that we use later for energy. So here's an example. One that he gives is of nitrogen, for example. He says animals and fungi accumulate nitrogen-rich substances, which, as centers of chemical free energy, become even more powerful agents of change. Their energy is also released through composition when, after death, they leave the thermodynamic field in which they were stable and enter the thermodynamic field of the biosphere. Here is atmospheric nitrogen. There's a lot of nitrogen in the atmosphere, which it's not in a form that's usable by most life, but microbes.
Rachel, for some reason the slide wasn't updating. It was still showing the old quote. Let's just try showing one more time.
Okay.
Because you're referring to a nitrogen cycle picture right now, right?
Yes.
Yeah, we were still seeing the text, so let's try bringing it up again.
Okay. All right, I'll try the play one more time. Let's see. Okay, can you see it now?
Yes.
Okay. Yeah, atmospheric nitrogen at the top, and you have bacteria which take in the nitrogen in the soil and convert it to a form that's usable by other living organisms. Okay, working now. Okay, one of the other examples he gave note of is the pressure of life, how it moves. Sorry, now I just need to move this thing so I can see the quotes. Okay, I guess I could see right here. Okay, sorry for the interruptions. Anyway, so this is going back to the criteria for different ways to look at life. And he says one thing is that it's always exerting a pressure. Living matter, organisms taken as a whole, is spread over the entire surface of the earth in a manner analogous to a gas. It produces a specific pressure in the surrounding environment, either avoiding the instances in its upward path or overcoming them. In the course of time, living matter clothes the whole terrestrial globe with a continuous envelope which is absent only when some external force interferes with its encompassing movement. Life will just take over. I think people probably have images of this. If you try to clear a forest, it's going to come back to you. Life has gone to, the furthest depths of the ocean, to extreme places where you would think it couldn't survive, but it finds ways to survive there. Another criteria he talks about is the speed of transmission of life. It says the speed of transmission of life over the maximum distance available to it will be a characteristic constant for each type of homogeneous living matter, specific for each species or breed. We shall use this constant to express the geochemical activity of life. And he gives examples of different examples. Termites, for example, if they were not stopped, they would be able to cover the entire surface of the planet. And that's the surface area. The distance he's talking about is the surface of the planet. They would be able to cover the surface of the biosphere in a few years, termites. Bacteria would be able to cover the surface of the planet in 36 hours if they were not stopped by any impeding force. Plankton, grasses, insects, all of these have very high speeds of transmission, of replication. And he says for each species, they will have a characteristic time, a speed at which that will occur. And that will be another expression of the distinction of that species. Just like you might have a chemical makeup of how much carbon, nitrogen, oxygen, what their specific chemical makeup is, and that's specific for each species. Well, these other things are actually also indicators, not just how an organism appears or something like that. Then the other characteristics, last ones he gave was the space. Oh, here's an image just of plankton, which quickly takes over space. Termites. Okay. Yeah, this is Pasteur. So Vernadsky also mentioned that there's something characteristic to life in terms of its symmetry and the shape of its space, which is not what you would generally think about with life. But he was very excited about this discovery by Louis Pasteur, who was looking at two forms of crystals of tartaric acid and racemic acid. They knew about tartaric acid first. You see this image, there's levotartaric acid on the left and dextrotartaric acid on the right. They knew about the tartaric acid of the left form, which they had discovered in wine barrels. But someone made a discovery of another acid, which was a residue of the wine process itself, but in a slightly different stage. And this was pretty much chemically identical, except that it did not rotate light in the same way. This is one thing they would look at is, put a solution, dissolve a material, into liquid form, put it in a polarimeter, which you see here on the right, put polarized light through it, and then see what occurred with the light. And depending on the solution, some of it would rotate the light specifically at specific angles. Some of it would do nothing. The light would go straight through. So the tartaric acid bent light to the left, and the racemic acid did nothing. And so they said, well, what's going on? Why are these so similar? Yet one of them rotates light and the other doesn't. So Pasteur actually got them down, was able to isolate out their individual crystals, in the form that you see here on the top left of A, and noticed that, in the tartaric acid, there was only they were pretty much identical, except they were only shaped in the one way. And, these are crystals that are sort of like your left and right hand. They're basically identical, but they can't be superimposed. And he noticed So he noticed that in the tartaric acid, they were only the left-handed, whereas in the racemic, there was both. And so he took the racemic acid and he was pasteurizing it, and he had a polarimeter on while he was doing this. And at the beginning of the process, the light went straight through, but as the pasteurization continued to go, it started to turn to the left. And at the time that it was fully completed, the light had gone to the maximum to the left, basically, exactly to where the tartaric acid would have gone. And so he said, well, what happened? Why is it that the yeast basically was selecting only the right-handed crystals, right-handed molecules in the solution and leaving the left? There was an active selection of a handedness of molecule that was being used. So this is what Vernadsky says about that. As we saw that in three-dimensional Euclidean geometric space, right and left-handedness are geometrically and physically equivalent in material processes. So in Euclidean, regular 3D space, geometric space, left and right are the same, are equivalent physically and geometrically. This equivalence shows itself in the fact that the numbers of crystallographically right and left-handed polyhedra that are formed during crystallization are identical in the absence of living organisms in the medium. This number corresponds to the laws of theory of probability, 50-50 of each type. And now I can't get it to move. Oh, here we go. Okay. Here, the inequality of right-handedness and left-handedness is acutely manifested. There is an enormous accumulation of material that has still not been worked through critically. But it seems to me that it can be firmly established on the basis of this material that in organisms, in living matter, this inequality is extremely pronounced for a whole range of diverse properties. It is transmitted hereditarily and is a species marker. All proteins exhibit a left rotation of the plane of light, both in animals and in plants. This means that in the complex matter of living bodies, only left isomers in protein bodies, that is the left molecules, the principal component of protoplasm, are stable. Right isomers are absent. As Pasteur demonstrated, all crystalline compounds, alkaloids, glucoses, sugars, etc., which make up eggs or grains, that is, which are the most essential for life, are left-handed. They also looked at things like products of trees, turpentine, sugars, camphor oil, oil of lemon, and these were all optically active. They would rotate the light. We also, Vernadsky, of course, was looking not just at even the material on the Earth, but on, he wanted to look at the relationship of nearby bodies in space, and noticed that on some meteorites, there's also a left-handed proteins and amino acids are dominant in some meteorites as well. So point about this is, why is that life is an active principle. It's actually actively selecting materials to take into it itself. Let's see here. This is, I'm just going to mention, he also talks about the fact that there are a lot of complexities in the periodic table of Mendeleev, who was a teacher. Vernadsky was directly a student of Mendeleev, who invented the periodic table, and looked at and said that there's a lot of things that it leaves to unknown. about what the elements are, what role they play, how they function in the universe. And one thing Vernadsky noticed is that he wasn't the only one, other people were noticing as well, but that there's a predominance of even atomic numbered elements in the universe and in the Earth's crust, and less odd numbered atomic elements. And this is just a graph of that. You can see, actually, the next one you might be able to see a little better, but the ones oxygen, silicon, calcium, carbon, lithium, these are all even numbered. So it might be a little easier to tell. Looking at number 1, starting with hydrogen, helium, and you see all the red ones are the even numbered. Carbon, oxygen. Okay. He also emphasized the relationship of the Earth to its surrounding environs, and said, similar to the question of life, there's also a continual material process between the Earth and the space around it, and that directly affects the biosphere, that the biosphere is not separate from cosmic space. And he gave the example of solar power as the most obvious fundamental connection, which is the source of energy for all life on Earth through photosynthesis, and then the consumption of the products of that photosynthesis by all other life, including what we use for electricity today. Most of it, oil, petroleum, is derived from solar power. Okay, there we go. Okay. Actually, no, this quote. It says, "The face of the Earth, viewed from celestial space, presents a unique appearance, different from all other heavenly bodies. The surface that separates the planet from the cosmic medium is the biosphere, visible principally because of the light from the sun, although it receives an infinite number of other radiations from space, of which only a small fraction are visible to us. We hardly realize the variety and importance of these rays, which cover a huge range of wavelengths." This is just an example of that, looking at the Earth compared to other planets, a difference in its appearance. Here's an X-ray map. This is another of the types of radiations that he mentioned, which are of great importance. It says, "Our understanding is full of gaps, but improved detectors are rapidly expanding our knowledge of their existence and variety. Certainly, they make the empty cosmic regions different from the ideal space of geometry. There's action everywhere, motion everywhere." Here's just another example of that activity: the sun, solar wind, the Earth's magnetic field. Besides solar radiation, energized particles from distant parts of the universe, gamma rays. He talks about aurora borealis, lightning, the illumination of the sky on dark nights, luminous clouds. These are all indications and examples of this connection. Stars and nebula are constantly emitting specific radiations, penetrating the atmosphere. The outer layer of the Earth must therefore not be considered as a region of matter alone, but also as a region of energy and source of transformation of the planet. To a great extent, exogenous cosmic forces shape the face of the Earth, and as a result, the biosphere differs historically from other parts of the planet. The biosphere plays an extraordinary planetary role. on the cosmic, his views towards cosmic connection. And lastly, from Vernadsky, look at a little bit at his idea of the noosphere. We looked at the lithosphere and biosphere. The noosphere is the realm of human activity. And he discusses this almost as much in some of his papers as the biosphere. It's not a nice, cute idea that you have life that does this stuff, and then you have mankind that's doing activity as well. But it's a fundamental component of I'll go through the idea, but it's the activity of man is actually more powerful than the biosphere. So he talks about the biogeochemical energy of living matter is determined primarily by the reproduction of organisms. But with man, the form of biogeochemical energy connected to reason grows and expands with time, rapidly moving to the fore. This increase is possibly related to the growth of reason itself, a process which seems to occur very slowly, if at all, but is chiefly connected to its honing and deepening in using it to consciously transform the social environment, and is especially due to the growth of scientific knowledge, which is also very much LaRouche's economics, the same exact idea he's pointing to about the role of scientific knowledge and scientific discoveries in transforming the noosphere, or LaRouche would say, the economy. Now, the Earth's human population has reached the previously unprecedented figure of nearly 2 billion people, despite the losses incurred by wars, starvation, and disease, which continuously afflict hundreds of millions of people, and which have seriously retarded the course of that process. It will require, however, only an insignificant amount of time in geological terms, barely more than a few hundred years, for such relics of barbarism to cease. This could, of course, be accomplished even now. The possibility lies already within man's grasp, and a will informed by reason will inevitably embark on this path, since it corresponds to the natural thrust of the geological process. This is even more the case as the opportunities for doing this are rapidly, almost spontaneously increasing. The real significance of the popular masses, which have endured these sufferings more than anyone, is irrepressibly growing. This is in the middle of 2 world wars. This is not a time that many people would be so extremely optimistic, but that's the sense you get from him, is a complete sense of optimism about the short time that it's going to take this creative power of mankind to overcome these problems that have been holding it back. In terms of what the noosphere is, more concretely, he talks about things like the development of the sciences of mankind, the discovery of fire, the development of new sources of power, steam power, electricity, agriculture is fundamental, husbandry, and then he also talks about the spiritual creativity of human activity as being even more important than some of the sciences which are directly related to nature itself, or investigation of nature. He says one of actually the most important are those things which are purely sciences of the mind, and that they increase the ability for new discoveries even more than the other fields. Human beings, we also create completely new fields of physical activity, new materials, the rate of yields of plants, we dramatically change, and we're now developing drought-resistant strains of rice and wheat. This is, wonderful. So mankind itself is a geological force. He says it's the most powerful geological force. So then LaRouche has started to study Vernadsky, at least in the 50s, but it wasn't until a little later, maybe in the 90s, which he really started to take him up. And it was through an investigation of a 1935 paper from Vernadsky that he said, I'm directly on board with all of his fundamental concepts. He said, the characteristics of the biosphere, as Vernadsky in his laboratory defined it, and noosphere, as I define physical economies as wholes, are analogous. Everything to which I have referred on this account in Vernadsky's 1935 paper has a parallel in my methods of a science of physical economy. The relations among products of the noosphere have an echo in the relations among the chemical elements circulating within the biosphere. So in the same way that Vernadsky would be looking at the action of elements in living processes, LaRouche was emphasizing studying more the motion of them in human processes. Okay, but then even going further, taking Vernadsky's concepts to an even further role was LaRouche did in a discussion in 2010, in a discussion with his scientific associates. And I think people are going to appreciate this concept. This is in a discussion on mind as the principle of the universe. He says, so I think we have to start from the galaxy. We have to say that this idea about life being something like a disease or a mushroom that grew up in the galaxy is nonsense. The point is, the universe depends upon the phase spaces of which it is composed. There was never a lack of any of these spaces. What we are able to do as human beings is to tap into the development of the noosphere, and the noosphere runs the universe, or the principle of the noosphere runs the universe. And in the universe, the living processes are higher than the non-living processes, exactly contrary to what the axiomatic hypotheses are. The universe is organized as a process of development. The principle of mind exists in the universe. It exists from the beginning of the universe. Whatever the beginning is, whatever the beginning means. Life, similarly inferior to cognition, also lives in the universe as a distinct phase, which is distinct from human creativity. And on the lowest level, you have the lithosphere. Oh, sorry, switch it. As long as you get this crazy model, you're always assuming backwards. You're assuming that the lithosphere is primary, that somehow you've got to figure out how the sawdust grew into something or other as a biosphere, and then the biosphere spun off the noosphere. Crap, it's the principles of the noosphere that run the universe. So the noosphere was there in the beginning. Where is it located? The problem is we're still doing this thing. We're still trying to build up the universe and its noetic features from dirt or pre-dirt. And the problem with the periodic table is it does that. It builds in the assumption that dirt is the basis for the solar system, and it's not, because the reality of the universe is noesis. The reality of human ability to change the universe is noesis. Noesis does not exist in sense perception. There's no way you could demonstrate noesis in sense perception except as a footprint left behind by noesis. So this is very much what science does today, or sense perception in general, they try to build something up from particles on up, from dead material, and that somehow builds up the rest of the universe. But he says that's the opposite way from what you have to do it. there's the living processes, which dominate the lithosphere, and there's noetic processes, which dominate the biosphere and the lithosphere. And everything in the universe actually is expressing that process of noetic development. So I am going to stop there, and Bill is going to take up take this discussion a little further.
Can you hear me all right?
Yep.
Okay, I think Rachel made a pretty good case for, as LaRouche and Vernadsky are teaching us, that the universe is developing. It's going from lower states of organization to higher states of organization. It's, I would say you could call it an optimistic universe. It's improving. That's the characteristic of it. Now, of course, we know that there's problems. And most of the problems are caused by a very small but powerful faction of people throughout history, and this has been going on for thousands of years, that believe that their class or their caste has a God-given right to run society. And they and to that end, they'll suppress anything that upsets the order that they have established. Now, what I want to develop further in referring to Linden's writings and those of scientists that he's identified as being crucial to human progress, despite these oligarchs, to develop this idea of how, despite the falsehoods, despite the dictatorship of these the axioms that we're supposed to accept, the imposition of rule by popular opinion dictated by these oligarchical forces, how mankind has gotten to evolve. And we're at a point where we have to make a choice. We got to decide if we're going to once and for all, as Vernadsky said, get out of this lower level where we're fighting and threatening. I mean, he's talking during World War I, World War II, all kinds of horrible things happening. And we are on the brink of what could be a nuclear annihilation war. So we're going to have to decide what kind of future do we want, or do we even want to have a future? And I would say the optimistic human rational choice would be to choose a future. But so let's look at how to think about this. And I want to present it sort of in terms of, if you recall, I had in one of the previous classes, I mentioned that LaRouche wrote this paper called The Science of the Human Mind. And at the very last sentence, he said that truth only exists in the form of polemics against evil and falsehood. Now, let me start with Plato and Aristotle. In Aristotle's Politics, he says, "But is there any one thus intended by nature to be a slave, and for whom such a condition is expedient and right? Or rather, is not all slavery a violation of nature? There is no difficulty in answering this question on grounds of both reason and of fact. For that some should rule and others be ruled is a thing not only necessary, but expedient. From the hour of their birth, some are marked out for subjection, others for rule. Again, the male is by nature superior and the female inferior. And the one rules and the other is ruled. This principle of necessity extends to all mankind." There you have it. Now, in Plato's dialogue, Meno, Plato has Socrates select a slave boy, has Socrates ordered Meno, who he's in dialogue with, to select a slave boy from his household. And through his method of dialectical discussion, he demonstrates that he can educe from within the soul of this child who has not been taught anything, to educe from this child the most advanced concepts of Greek geometry and mathematics. One of them, incommensurable magnitudes. Now, Socrates is known for his for stating that the only thing he knew for sure is that he did not know. But there's another quote from Socrates that you might not have heard, and this is also from Meno. And the subject of Meno is, can virtue be taught? And then first of all, they discuss, is there such a thing as virtue? What is it? And then they discuss, can you teach anything? And he's already demonstrated that he could, like I said, get the boy to discover advanced through the proper questioning. Now, what Socrates says, it's not just a question, oh, I know, the only thing I know is that I don't know. Socrates says, one thing I'm ready to fight for, as long as I can, in word and in act, that is, that we shall be better, braver, and more active men if we believe it right to look for what we don't know, than if we believe that there is no point in looking, because what we don't know, we can never discover. So you could make a choice if you want to live in the universe of Aristotle or the universe of Socrates and Plato. Now, I'm gonna base what I'm saying mainly on two writings from LaRouche. One is from 2014 with the wonderful title, "The Satan Still Operating from the Corpse of Bertrand Russell." That's basically, again, demonstrating this conflict and, posing the choice, not really a choice, between Bertrand Russell, who wanted to reduce all of science to mathematics and reduce all of mathematics to logic, and therefore eliminate the creative power of the human mind. And he did this in around the early 1900s, and soon after he was completely destroyed by Kurt Gödel's proof that you can't even reduce arithmetic to logic. And I won't go into a lot of detail, but in the course of that, I mean, LaRouche applauses the refutation by Gödel based on mathematical logic, but he says it's not adequate because the real refutation is in physical science. So basically in this paper, he describes two sets of experimental evidence regarding principles of physical science. And he gives an example of the triad of discoverers. Number one, Filippo Brunelleschi, who is an example of the progress of physics in the small. Number two, Cardinal Nicholas of Cusa, for physics of the very large and a resolving, unifying, underlying universal principle discovered by Johannes Kepler, the principle of the solar system, and not just a solar system deduced from some axioms about matter. And he says all competent physical science since that triadic achievement itself has been rooted in its already given foundations and has been implicitly defined for all competent practice of science since by the triad of Brunelleschi, Cusa, and Kepler. That up to a certain and later crucial point in the progress of modern science. Now later we're going to explore another triad that he identifies which is the triad. We've touched on this. He refers to the necessary role of in between before the modern triad of Carl Friedrich Gauss and Bernard Riemann, but we'll come back to that. But in the modern era, he says that you have an echo of the work of Brunelleschi in the small, Kusa in the large, and the unifying principle of Kepler in three scientists that did their greatest work in the 20th century. Max Planck, who we discussed before when we were going through the machine tool principle. Number two, Albert Einstein, who we'll talk more about his discoveries. Well, he's probably the most well-known. And then LaRouche describes the third in the triad as being Vladimir Vernadsky. He describes it as the approximation. He describes Vernadsky's work as an approximation of a still wanted third completed statement, preferred but not yet attained in principle, comparable in effect to the precedent of Kepler's unique element in respect to the treatment of the principle of life per se. He says that Vernadsky echoed this role of Kepler in a useful approximation, but without completion. So that means, thankfully, that there's work for us to accomplish in this regard. So let's dive in here. Let me see here. I'm going to come back to that. Oops. Okay. Well, let's begin with Brunelleschi. Okay. He's your ultimate Renaissance man. Born in 1377, passed away in 1446. Okay, now Brunelleschi's dome. Now LaRouche says that, well, how is this a demonstration of the physics of the small? All right, this dome was built on the top of a drum of a cathedral. It's in Florence. This dome, you see, it weighs
are you
30.
You need to turn on your sharing there, Bill?
Oh, the sharing's not on. Oh my goodness. Let's see. Oh. All right, I'll get it eventually. Share screen. Do you have it now?
Yes, sir. Thank you.
Okay. This beautiful dome, cupola, on top of this cathedral in Florence. It's 37,000 tons. Consists of 4 million bricks. 42 meters across the diameter of the base. By the if the physics of the universe were based on straight lines, this wouldn't be possible. It wasn't built by the method, let me show you, that commonly would be used, where you would build some scaffolding underneath out of wood. It would have taken all the wood in the area of Florence to do this. The bricks were laid such that each layer of brick supported the next layer. So it was completely self-supporting. So like I said, 4 million bricks. And the laying of the bricks was guided by a non-linear principle identified with the shape of the catenary. Catenary is the shape of a hanging chain. You see, these young people are re-experiencing the process of discovering the principles of the catenary curve. And now there's an illustration here that shows you, this is a model that was built by a professor who's been studying the construction of this cupola for his entire life, Massimo Ricci. You see, this is a house-sized model of the Brunelleschi cupola. And if you can see, the layers of bricks, they're in curves. And the curve is determined by a chain that was hung between the 8 ribs that guide the upward curvature. You can see it better here. You see that's a curve, and that curve, that was based on a hanging chain. Now, this was, we'll get more into the principles of how this was, of what is involved here. But I think the point about it is, as LaRouche said, the physics of the small. Now, there's also a catenary principle in the way the arch is shaped, just quickly. Anybody who's ever seen the St. Louis gateway to the west arch will see that that's an inverted catenary, like these young people are building here. So there's a multiple use of this principle of the hanging chain, which is a curve that is created by physical action, not by any axioms of geometry. I guess I should mention here that if you've read LaRouche's autobiography, he talks about how when he was first in a geometry class, he was made fun of when he tried to bring up examples of construction principles as the basis for geometric forms, as opposed to the textbook teaching axioms and postulates of geometry, which he never accepted. He refused to accept. He believed that geometrical principles were based on physical principles. So that was a very crucial point in his life, and he's always been rebelling against the dictates of popular opinion and the dictates of those that want you to accept as self-evident axioms what you're told. Don't believe your mind, believe your rulers. That's one way to put it. Okay, so the second in the triad was Nicholas of Cusa. So first we had Filippo Brunelleschi versus Euclid. So now we go to Cardinal Nicholas of Cusa. Now, LaRouche has often said that modern science begins with Cusa's work on learned ignorance. So I want to read you a quote from there. Just make sure I have the right ones here. Okay. Now I want you to follow this reasoning. We can't get in too deeply into it, but when we get to Q&A, maybe you want to ask about this. And LaRouche says this is where modern science begins. Cusa says that if you're going to, following with Socrates, the only thing you know for sure is that you don't know. And he says we have to reach the maximum of knowledge, we have to achieve the maximum knowledge of our ignorance. So the quote here, since I'm going to discuss the maximum learning of ignorance, I must deal with the nature of maximality. Now I give the name maximum to that than which there cannot be anything greater. What fullness befits what is one. Thus oneness, which is also being, corresponds with maximality. But if such oneness is altogether free of all relation and contraction, obviously nothing is opposed to it, since it is absolute maximality. Thus the maximum is the absolute one, which is all things. And all things are in the maximum, for it is the maximum. And since nothing is opposed to it, the minimum likewise coincides with it. and hence the maximum is also in all things. And because it is absolute, it is actually every possible being. It contracts nothing from things, all of which derive from it. In the first book, I shall strive to investigate incomprehensibly above human reason this maximum, which the faith of all nations indubitably believes to be God. I shall investigate with the guidance of him who alone dwells in inaccessible light. Okay, maximum ignorance. And again, LaRouche says that this is where modern science begins. So what is modern science? To come to make a science of knowing that you do not know? Well, I'm going to let you stew on that. Now, there's another quote that is very crucial to this point. And you could say that this is I don't really want to denounce Archimedes because he was quite an inventor and discovered some pretty important ideas in geometry. But another of Nicholas of Cusa's very important writings, essential to the progress of real science in terms of discovering what are the qualities of the universe, what are the principles that underlie what we observe in the universe. And it's his treatment of the question of the quadrature of the circle or squaring the circle. Can you construct a square area out of a circle, or construct a square that has an area equivalent to the circle? And rather than approach the method of Archimedes, which I think Jason and Daniel dealt with this in the first class. Archimedes' method is to say that you can inscribe and circumscribe a circle with a polygon. And the more sides you add to the polygons inside and outside the circle, the closer you get to constructing polygons, and the difference between the area of the polygon, the polygons reduces, and they get closer and closer to the area of the circle, and therefore you can eventually have the resolution of the circle and the polygons. But Cusa takes the approach, no, the nature of the circle is the opposite of the nature of a figure made of straight lines. And the circle is one action. The linear action, especially in polygons, you have a linear action, no change in direction, and then suddenly a change in direction, and then linear, and then a sudden change in direction. And this is the opposite of circular action. So just quickly what he says about that on the quadrature of the circle, right near the end. And this is very applicable to not just this question, but every question of science. I have made clear to you everything that one can know about the equality of the perimeters of curvy and rectilinearly bounded figures, namely, that the following comes closer to the truth. One cannot know equality, and even that which one can know most precisely in this area is made clear by a short proposition. With that, I have fulfilled your wish as well as I could. You must know you have, with that, a method to investigate everything that can be known mathematically. In mathematical science, any proposition from which the precise equality of circle and square follows is impossible. And any proposition through whose opposite the precise equality could be introduced is necessarily correct. I even affirm, whoever understands in mathematical science to lead every investigation back to this, has achieved the perfection of this art. Because here is absolutely nothing true, from whose opposite the equality of circle and square would not follow. And that is the totally sufficient solution of any mathematical investigation. And I think you can apply that same thinking to the question of artificial intelligence. Are we ever going to design a machine based on a digital machine or any other machine that is going to be able to create cognition, thought, human creativity? I mean, I'm sure there's plenty of machines that can imitate plenty of different people that you've met in your life, but can you actually, is there something about intelligence, human thinking above and beyond that which a machine can generate? And I think this is very relevant to that question. So let's see what's next. Okay, so we have Brunelleschi, for physics in the small. We have Kusa. Well, he's taking on the absolute maximum, so that's obviously physics of the large. And then, as LaRouche describes it, the unifying universal principle discovered by Kepler of the organization of the solar system and the discovery of the principle of universal gravitation. So, oh boy, something's getting in the way here.
Are you trying to? Okay.
There's something, the screen sharing thing is.
Would you like to move to another tab that's already open?
Down. Oh yeah, that's what I'm trying to do.
Hold Control and press the Tab key.
Control and what?
Tab. On your keyboard, hold the Control key and press Tab, and that'll move you to the next tab.
I don't see a tab. I see Shift. Is that what you mean?
Above the caps lock key is a key that's the Tab key.
Oh, that's T. Yeah. Boy. Tell you what.
You can drag the little Zoom thing that says you're sharing your screen. You can drag that around too. Okay.
This will do the trick. Oh, I have to go for it. Well, this is a diagram of, from Kepler's work called the New Astronomy. Now, in New Astronomy, Kepler basically, again, I talked about you have to defeat the imposition of oligarchical popular opinion, not just amongst the population, but amongst the population of those who are represented as your scientists. Now, Kepler had to take on Ptolemy, Tycho Brahe, and Copernicus. And it's not necessarily that, he hates these guys. He's just trying to assert that there's a principle of truth that is not served by astronomy as it had been practiced for thousands of years in terms of describing the motion of planets or describing the motion of the lights in the heavens. It's not about, for Kepler, what he did was he showed how both Ptolemy, Tycho Brahe, and Copernicus, they could all give you a narrative, a plausible narrative to describe the motion of the planets, even though they were all based on completely different assumptions about the reasons for the motion. And the reasons weren't really reasons. They were just mathematical descriptions based on different forms of circular action on circular action, known as epicycles in the case of Ptolemy, And also, well, I guess all three use that kind of principle. And then there was also the principle of the equant. They put everything hit, which is a circle where the motion was non-uniform, but supposedly you could pick a point in that circle so that you could justify the idea that the motion was not uniform circular motion, but it was still on a circle. Now, and Kepler had to destroy this idea that the orbits were circular because it wasn't based on reason. It was, I mean, it was an assumption that wasn't to be challenged. Now, the other thing, Kepler wanted to, he insisted that there had to be a reason for these planets to move around in the orbits that they move in. And he identified the reason for that is a cause located in the sun. Now, so you can see that this is a, when LaRouche says a unifying principle of the physics of the large and the small, well, obviously we're dealing with planets moving in orbit, so that's quite large. But if you see this diagram here, Kepler's method for determining that first of all, I have to say that once Kepler was able to demonstrate that Mars you could not create a circle that would that corresponded to the motion of the Mars orbit, he put forward the idea of the ellipse as the geometric form that the orbit takes. But he also established the principle we now know as Kepler's second law, that the planet sweeps out equal areas in equal time periods. But rather than get into all of that, one crucial element of his method was to divide up the orbit into these, you see these triangular sectors. And he's dividing them up, finer and finer to describe the changes, because the orbit is completely non-uniform. It slows as the planet is further away, it's moving slower, and as it gets closer to the sun, it's speeding up. Now, the fundamental idea there was, well, Kepler put out a challenge to future mathematicians to figure out methods to deal with this problem. And this is the root idea of what we know now as the infinitesimal calculus. And it's about a principle operating at every infinitesimal interval. So you have this orbit, which is of an astrophysical scale, a motion of a planet. But the principle that's causing the motion is acting at every smallest interval to change the direction of the motion of this planet. So that's how you see the unification of the physics of the small and the physics of the large. And I mean, there's a lot more to this, but we can take up some of it in the Q&A if we have to. And you've got an expert moderating here, so maybe he might have something to say about it. Don't blush. Okay, let's see, where's it gonna go from here? I'm losing track here. Okay, now in this discussion about the triads, so we have the first triad from the period from the Golden Renaissance up through the 30 Years' War. Brunelleschi, Cusa, and Kepler. Now, LaRouche doesn't explicitly mention it, but I have to because he's essential to the progress of science, and he's my boy. That would be Gottfried Leibniz. Now, Leibniz, if you want to talk about refuting oligarchical opinion, he's up against Descartes, he's up against Isaac Newton, he's up against the Royal Society. he is the preeminent representative of this idea that that the universe is not dominated by fixed laws, but it's dominated by a principle of development and principle of perfection. Now, let's see what I got here. Oh boy. I'm trying to, you said to hold this control and, well.
And tab, the key that's to the left of the Q.
Yeah, tab, yeah. Doesn't seem to be working.
You can also drag the green share screen thing. You can drag that around on your screen to move it out of the way.
Oh, there you go. All right, maybe that did it. Here we go. All right. Now that there, do you see the paper clips?
Yep.
That's a model, that's an artifact from somewhere in the, ruins of Boston. In 2005, a group of people working in the LaRouche youth movement, we were working on investigating the principles of the calculus, and particular what LaRouche called the catenary-cued principle of universal least action. Now, I mentioned before when we were talking about Brunelleschi's dome that the pattern of that was used to lay out the bricks was based on a slack chain, they called it, a hanging chain or a catenary. Now, the shape of this curve is determined by the principle that was first identified by Leibniz as the principle of least action. And he describes it this way in numerous of his papers. And it's essential to this idea of the infinitesimal calculus, a universal principle acting at every interval of action. So in a writing called On the Ultimate Origination of Things, Taken at Their Roots, Leibniz says, in all things, there exists a principle of determination one can derive from the idea of maximum and minimum, i.e., how a maximal effect is obtained by a minimum of effort. In this fashion, a liquid introduced in another one, heterogeneous, takes the form which has a maximal capacity, that is to say, the spherical form. Also, in ordinary mechanics, the action of several interconnected weights, for example, a chain, results in the movement by which finally the largest descent is realized. Now, we studied this chain, and we looked at the treatment that was done by Bernoulli and Leibniz. They studied it exhaustively. They were the first ones to be able to actually come up with a mathematical representation of that curve. Yeah, I mean, for example, like Galileo thought that the chain was forming a parabola. And a parabola is a function that's based on a square. If you represented it algebraically, a parabola would be something like the y-axis. The y-coordinate changes as the square of the x. So as you go one by one by one horizontally, vertically, the height increases by squares. And all of Descartes' so-called analytic geometry, which was actually developed by Fermat in much better fashion. I mean, everybody's been brainwashed with X, Y, Z coordinates. They thought you could describe every curve by algebra, that there were algebraic functions, powers of X, that you could describe that curve. But Bernoulli, working with Leibniz, showed that the curve is based on a completely different principle that came to be known as transcendental functions, which cannot be reduced to algebra. And there's another example of this business about, if you can take that difference back to the question of the circle and the square, square and the circle. The transcendental functions, they transcend arithmetic operations of addition, subtraction, and multiplication. But see, the thing about this curve is it's determined by a physical principle, and can't be described by some kind of algebraic principle. Now, you'll be hearing more about that in a minute. So just quickly, it's getting kind of late, so I need to speed up a bit. But now, as LaRouche described the two triads, in between the triad of Brunelleschi and Kusa and Kepler, he identified the important role that was played by Carl Friedrich Gauss and Bernhard Riemann. I'm going to really have to get through this. But when we're going to talk about overturning axioms and defeating oligarchical popular opinion, I mean, Gauss is the guy who, when he was 10 years old, he was in class and they told, the teacher said, I want you to add up all the numbers from 1 to 100. And he figured that's going to keep the kids busy for the entire hour. And then Gauss gets up a minute later and says, here's the answer. You might recall that story. And if you don't know how to do that, by the way, that's something that you should try to figure out. Now Gauss, he took on Euclid, although he didn't publish much about it. He basically had figured out that the idea of Euclid's elements, that geometry must be flat, that was, quite questionable. He took on the mathematicians Euler, Lagrange, and others who used the idea of the square root of -1, or what we now call complex numbers, as a algebraic fact that popped out when you're trying to solve equations that they create a mystery. There's nowhere on a number line of starts at 0 that goes to positive infinity and negative infinity. There's nothing on a number line that corresponds to the square root of -1. But these guys, Euler, Lagrange, etc., they're doing all these calculations based on this number that they have no accounting for. And that's why even still today, we call them imaginary numbers. But Gauss demonstrated, I guess he was 22 years old. He was the first to prove what's known as the fundamental theorem of algebra. And in the course of proving that, that every algebraic function of a n power has n roots. Well, that's not exactly what he proved, but it corresponds to that. But he proved that this idea of the square root of -1, or numbers based on real numbers and imaginary numbers, that they weren't imaginary, that in fact they just corresponded to an entirely different concept of magnitude, which enables the development of a completely new fields of science, like gravitational potential, electromagnetic potential, things like that. So, I mean, he was a revolutionary. Now, one of his students was Bernhard Riemann, who only lived 40 years, or 39 years. But he dealt the final blow to Euclid's elements. And we talk more about what's the deal with Euclid's elements. But he took on the idea that you could just arbitrarily set down a set of axioms and postulates as to the organization of space, and announce once and for all that all of geometric truth can be derived from those assumptions. Now, like I said, it's getting late. So let me just point out that Riemann, he developed this, he developed the generalized non-Euclidean method of geometry that was essential to discoveries that were made in the future by one of the other of the second triad that LaRouche identified. And that triad, this is the triad of people that were researchers that they did their main work in the 20th century. Let me go back to this idea here. The second triad, Max Planck, echoing the role of Brunelleschi in the physics of the small. As we talked about in the third class, Planck discovered the quantum of action. And he was very explicit that this principle of least action was fundamental to, he said it was a higher level principle of physics than even the conservation of energy, which he held in very high esteem. He said that the least action principle was a much more important role. And he gave the credit to Leibniz, which was not in fashion in that day. But in solving the question of black body radiation, Max Planck discovered that electromagnetic radiation came in discrete packets or quanta. Now, the second in the triad, the universally well-known Albert Einstein. Let me skip here. So you have Einstein and Planck. So Planck, he announced his quantum theory in 1900, right at the end, December 1900. Albert Einstein, as we discussed, he applied Planck's quantum theory to light, and he showed that the photoelectric effect was something that couldn't be explained by classical physics, as they called it, was due to the quantization of radiation. Now, LaRouche identifies him as corresponding to Cusa in terms of the physics of the very large. Now, Einstein played a very crucial role for the physics of the small as well. So it's kind of both Planck and Einstein there. But for the physics of the large, in particular general relativity, he corresponds in this pedagogical discussion to Nicholas of Cusa. And I think in particular, LaRouche was thinking of Einstein's concept of the universe as being finite but unbounded, or as LaRouche would put it, finite and self-bounded. And then third, corresponding to Kepler, we have the accomplishments of Vernadsky, which LaRouche identifies as an approximation, but without completion, of a role similar to Kepler. Now, all of this that we're discussing, these represent revolutions in science. Brunelleschi, Cusa, Kepler, Leibniz, Gauss, Riemann, Max Planck, Albert Einstein, and Vernadsky, and I must say LaRouche, because they increase mankind's power over the universe. The increases were not created because they discovered some particular little fact that wasn't known. I mean, most people, their concept of science is, well, they wouldn't say that the most fundamental aspect of science is the human mind, but all of these men understood that. What they revolutionized was the way we thought about the universe. And as we talked about in the machine tool principle, the idea is there's always a hypothesis of how the universe works. But in the pursuit of truth, as opposed to ideology or some kind of ideological domination, you're seeking to understand, well, the goal should be to figure out, well, what about this hypothesis of the universe doesn't work or breaks down? You're always pushing the limits. And when you discover a new principle, like you discover an anomaly, like Kepler just could demonstrate that there was no circle, there was no circular orbit that could explain the orbit of Mars. Max Planck said there's no way that electromagnetic radiation could be continuous without discrete quantum of action in light. The universe would be bathed in an ultraviolet catastrophe of infinite radiation, and none of us would exist. And that's what the classical theory based on Maxwell's equations, et cetera, would have indicated. So he was able to show, revolutionize science. And as I discussed in the other, the third class, that discovery, that revolution also led to Einstein's accounting for the photoelectric effect. This led to a whole new technology of lasers, other technologies as well, which revolutionized mankind's power over nature. And there's other examples. But this is progress. This is development. This is characteristic of the universe. And there's a lot more I wanted to say, but I'll just throw this promise out to you. We have our Sunday night 8:30 in-depth session, and we're going to be going through the ideas in one of LaRouche's papers called Vernadsky and Dirichlet's principle. And there, what we're going to delve more into this process and these discoveries. Now, I have to, just to wrap up what I've got here, I'm going to bring this back to the end, to some important ideas in Vernadsky and LaRouche's take on it. So I just, to complete the thought, I want to get to that here. Now I'm going to read you three quotes from Vernadsky's paper, some words about the noosphere. Now, again, Rachel covered, this idea that is in Vernadsky, that from the abiotic domain, the processes that appear to be the abiotic domain that dominated the planet were overtaken by a new principle, the principle of life or living matter, and that transformed the surface of the earth in a way much faster, with higher states of organization, than anything that happened before the emergence of life. And in the same way, humankind came to be. Now, just a couple of aspects which are exemplified by these discussions. And this is from Vernadsky, some words about the noosphere, 1943. James Dwight Duana, an American geologist, mineralogist, and biologist, pointed out that in the course of geological time, at least 2 billion years and probably much more, there occurs an irregular process of growth and perfection of the central nervous system, beginning with the crustacea, whose study Dana used to establish this principle, the mollusca, cephalopoda, and ending with man. It is this phenomenon he called cephalization. The brain, which has once achieved a certain level in the process of evolution, is not subject to retrogression, but can only progress further. There's a lot of people that need to be reminded of that fact. Proceeding from the notion of the geological role of man, the geologist A.P. Pavlov, in the last years of his life, used to speak of the anthropogenic era in which we now live. While he did not take into account the possibility of the destruction of spiritual and material values we now witness in the barbaric invasion of the Germans and their allies, slightly more than 10 years after his death. He rightfully emphasized that man, under our very eyes, is becoming a mighty, ever-growing geological force. In the 20th century, man, for the first time in the history of the Earth, knew and embraced the whole biosphere, completed the geographic map of the planet Earth, and colonized its whole surface. Mankind became a single totality in the life of the Earth. At the same time, owing to the mighty techniques and successes of scientific thought, radio and television, man is able to speak instantly to anyone he wishes at any point on our planet. Transportation by air has reached a speed of several hundred kilometers per hour and has not reached its maximum. All this is the result of cephalization, the growth of man's brain and the work directed by his brain. Now, I particularly like this quote from Vernadsky because it's the only direct demonstration of this principle that LaRouche identifies as your measure of the power of your economy. The ultimate test or proof of the validity of a scientific principle is, does the application of that principle increase mankind's potential relative population density? Okay, now here, I'm not going to read it all, but Vernadsky cites the work of G.F. Nicolai. He's a physiologist, and he wrote a 600-page book, polemic called The Biology of War. And he was denouncing the participation of Germany in World War I. But very optimistically, he calculates that, and this is given the technology that existed in 1918, when the population was a little bit, the world population was a little bit less than 2 billion. He estimates that using the technology that exists, the methods of agriculture and machinery and energy, that it would be possible to support a population of 22 billion people on the Earth. But then he actually says using new energy sources. Now, again, this is before the nuclear age. But he's saying using the technology that existed, the best technology that existed in 1918, 1920, that you could actually support a population on the Earth of 3 trillion people. Now, I'm not sure we want to do that, but think of the optimism embodied in that. And then, of course, Vernadsky modifies that, saying, well, this is 20 years before anybody figured out how to use the energy of the atomic nucleus. So we should now more simply say that the source of energy subject to man's reason in this energetic epoch of the life of man on which we have now embarked is practically unlimited. Now, I did a little calculation. If the whole world had a population density corresponding to Japan or England, it would be something the world population could get to 50 billion. Now, to get into the order of 3 trillion, I think you'd have to have a population around the world equivalent to the population density of Hong Kong. I don't know if that's such a good idea, but that would get you just shy of 1 trillion people. But I think the point is clear. I mean, obviously, we're going to take mankind into the heavens further than we have now. Now, this is where I'm wrapping up. How can thought change material processes? Here, a new riddle has arisen before us. Thought is not a form of energy. How then can it change material processes? That question has not as yet been solved. Maybe one of you out there is going to solve it. I'll put that challenge to you. Now, in this last section, from some thoughts on the Noosphere by Vernadsky. The Noosphere is the last of many stages in the evolution of the biosphere in geological history. The course of this evolution only begins to become clear to us through a study of some aspects of the biosphere's geological past. Let me cite a few examples. 500 million years ago, in the Cambrian geological era, skeletal formations of animals rich in calcium appeared for the first time in the biosphere. Those of plants appeared over 2 billion years ago. That calcium function of living matter, now powerfully developed, was one of the most important evolutionary factors in the geological change of the biosphere. A no less important change in the biosphere occurred from 70 to 110 million years ago at the time of the Cretaceous system, and especially during the Tertiary. It was in that epoch that our green forests, which we cherish so much, were formed for the first time. This is another great evolutionary stadium analogous to the Noosphere. It was probably in these forests that man first appeared around 15 to 20 million years ago. Now we live in the period of a new geological evolutionary change in the biosphere. We are entering the Noosphere. This new elemental geological process is taking place at a stormy time in the epoch of a destructive world war. But the important fact is that our democratic ideals are in tune with the elemental geological processes, with the law of nature, and with the Noosphere. Therefore, we may face the future with confidence. It is in our hands. We will not let it go. So, you see, it says we have a conference in 10 days. And that conference is to make sure that we do not end the human race in a destructive world war, which we are quite certainly headed for unless there's a change in the leadership. So April 9th, we have this conference to discuss creating a new security and economic development architecture. We've got to put the ideas of Vernadsky and LaRouche and apply the science that's been developed by those great figures that we just talked about. We've got to put that new system into being. And I urge you all to join this optimistic view of the universe and be part of the organizing. We can't let all these great ideas perish. So let's move on. Go ahead, Jason.
It's a good idea. So we're turning now to our Q&A session here. So if you are on YouTube, you can type down your question there. If you're on Zoom, just raise your hand. A couple have already come in. You can also send an email if you want, questions@laroucheorganization.com. I'm just going to give a moment for anyone in Zoom to raise their hands. Otherwise, I'm going to turn to a couple that arrived on YouTube. Okay, let me turn to one then from, well, I've got a question too here. So let me just kind of add, I'll put a couple of things together that I'd like to get your thoughts on. Bill, picking up on the April 9th conference, the Schiller Institute conference that you mentioned, which everyone should participate in and direct others to as well. One of the aspects of this conference, it's about creating a new security and development architecture for the world. So I'd like to ask you and Rachel, what would be lost if LaRouche's views, the Schiller Institute's views, if Vernadsky's outlook were not brought into play in the creating of a multipolar world? In other words, there's a number of people that are recognizing that the situation in Ukraine, the fact that sanctions just don't work, that regime change is running into a brick wall at this point, that this means that the unipolar world order is over. Something will replace it. What will be the type of that multipolar world? Is this just a more diffuse form of power? Is there something guiding that world order that should be there? You've already addressed this. Essentially, it's the topic of what you've gone over. But I wonder if you could if there's anything you'd like to say, from that standpoint. What does Vernadsky, what does LaRouche bring to this this idea of what kind of world order we will now have, or create rather?
Well, relations have to be based on a different principle. I mentioned that the first triad ended right in the middle of the 30 Years' War, and that was a war that could have completely destroyed civilization until it was realized that the relations between nations and religions, et cetera, have to be a different principle. And the Peace of Westphalia, which I believe was concluded in 1648, the principle of the benefit of the other was established as the principle of international relations. That may seem completely unrealistic and crazy to people who come from the culture that we're in, but this was the basis of the agreements. Now, we've had on the table for almost 10 years now, they offered the Chinese to the rest of the world to join the Belt and Road, and most of the population of the planet have joined this, either in intention or in fact, have joined the process of creating a new infrastructure system led by, I mean, the Chinese have led it, but they've offered to the United States many times to be a part of this. And I mean, this is the only way to go. I mean, again, we're not animals. We have minds. We can conceptualize a future, and then we can build a least action pathway to that future. So, looking at the way things are now, we have the ruling class in the Western world, or you can take the United States for an example. We've been told for decades now that Putin is a dictator. He's evil. He wants to expand Russia, etc. You know, we're told that the Chinese can't be trusted, that they're trying to colonize Africa by building power plants and railroads and giving the Africans a modern economy. That's just their sneaky plot to take over the world. Okay, so if it's axiomatic that the Russians are our enemies and the Chinese are our enemies, where the hell are we going to end up? If you don't change that axiom, if we don't base our policy on some different concept, like say the benefit of the other or the benefit of development. I mean, the Chinese Communist Party, they actually set a goal. I mean, they said set the goal to lift people out of poverty, to eradicate poverty in China. And by their standard, they've done that. But they also set a goal to eliminate poverty worldwide. Now, what has to happen in the United States to get Congress and a president that is say, hey, that's a great idea. Why don't we set up a financial system that's going to make sure that that happens? What about the trade agreements? Can we join the Belt and Road? You know, what can we do? What can we cooperate to do? Now, you see, the good thing is this has all been figured out by Mr. LaRouche. In the call for this conference, it specifies the principles, the economic principles to have this new development architecture. It's the 4 laws. And the 4th law is the Advanced Fusion Program, a crash program to develop nuclear fusion. And in LaRouche's statement of the 4th law, Vernadsky's ideas play a central role. So there's definitely a cultural basis, not like supposedly among all these people in Europe that were slaughtering each other and burning villages and murdering babies, they were all Christians. I guess at a certain point they realized that they actually had to be Christians to survive. Well, here we go. We've got Lyndon LaRouche, the American. You've got Vernadsky, the Russian, Ukrainian. Same idea. Use man's technology to improve the conditions of mankind worldwide. So it's Noosphere or bust. Rachel, what are you?
Yeah, I'd like to add on to that. One thing is the celebration of collapse. You know, some people are happy that the Western sphere is collapsing or taking a celebratory note about it. And I can understand wanting, evil to suffer. There certainly has been evil done, by these powers, but yeah, will that allow for greater survival of the human species itself? And yeah, Helga LaRouche brought up the other day the LaRouche's emphasis that the nation state is not the be all end all of mankind, that just like other species have to progress to survive, or they'll go extinct. You see the evolution of higher levels of life. Well, the human species has to evolve as well. So it really is time that we have to think as mankind, and the power is actually within the population. I think the pessimism comes when people feel like there's nothing they can do about it. But the point is that the power of the change is there within every single person on the planet. It's just a matter of awakening it and making people cognizant of it, which is more organizing. So that's what the conference will be there for.
Good, thank you. Let's see if there's anybody. There's another question from YouTube, but I'll first see if anyone on Zoom would like to raise their hands. If you're on Zoom, you need to raise your hand to be able to unmute. Okay, not quick on the draw. Okay, if we're going back to a YouTube question then. This one is from Adam, and I think, Rachel, why don't you take this one up first? Adam says, doesn't the discovery of the Noosphere by Vernadsky show the lie of Extinction Rebellion and the other eco-crazies who believe that man is a cancer on the planet? And I'd also like to add, if you could sort of, what is, you were talking about evil getting its comeuppance, and that's a good feeling to have. You got to talk about what you're going to replace it with. If you'd like to, I hope you'll maybe say something about the background of Extinction Rebellion, or about this green idea. I'm sure you will anyway. So.
Yeah, the specific role of the specific background of the Extinction Rebellion.
Well, not them in particular, but
Okay, just bankers wanting to pretend that they're doing something good for mankind by limiting the power of mankind. Yeah, I mean that's basically what the Green Movement and Extinction Rebellion is about, is convincing a lot of young people who have not been trained in Vernadsky and Gauss and LaRouche that they are going to have a cancerous effect on the planet, when in fact, as Vernadsky showed, yeah, it's absolutely the opposite. And that's the great thing about Vernadsky, is it's empirical. It's a foolproof demonstration of the power and the role of the mind. And as LaRouche, the quote I gave at the end about you see the noosphere only through reflection. He demonstrates that irrefutably, that there's an increase of physical exchange of material based off of the mind. And yeah, that is absolutely a refutation of environmentalism, which has no real basis to its argument except for the fundamental axiom of environmentalism is that human beings can do nothing to change the universe, when in fact, absolutely, it's the opposite.
Okay, Bill, anything you want to add on that one?
Can I share the screen for one more time?
Yes.
Okay. Let's see if I can pull it off here. Okay, this is the last image I wanted to share. Where did it go? All right, anyway. I'll just say that my whole life I've been hearing that there's too many people in the world. I even remember there was a guy with a computer demonstration showing how our resources were being used up too fast. It was supposedly a model of the world economy. And he had all these different dials and buttons to push to show how if we could change the allocation of resources and priorities, how things would change and how things could improve or get worse. And I knew exactly what he's going for at a certain point. And I said, why don't you reduce the population? And then, of course, when they reduced the population on this machine, everything went perfect. And about 10 years later, when I met the LaRouche movement, I realized what that was. You know, and what are we told? And see, and when you do one way in high school, and then you go to college, and then they tell you about the second law of thermodynamics, that no matter what you do, it's ultimately not going to matter because the universe is running down. So they take this pessimism and they put equations on it and tell you there's really no point to your existence. And that's how you can get a bunch of kids to, you know, give up advanced technologies like soap and water and, you know, throw themselves in the street to stop science, to stop technology. Or this is how you can get people to believe that that being trained that the universe is running down and that mankind is a cancer to get degrees and consider themselves educated. You know, this is, I mean, it's a cultural question. And that's why I mean, part of it is involved in how you educate your children. And again, you know, we have to have a concept of the future, not just for ourselves, but for, you know, the generations after us. Do we live for ourselves or do we live for everyone, our brethren? I mean, this country was founded on an idea that it wasn't just for the benefit of the people who lived there, but it was a benefit of your posterity. I'm going to shut up because I see Harrison has a question. So,
yeah, let's turn to Harry next. Go ahead. Can I unmute yourself?
Unmute.
Can I be heard?
Yeah, go ahead.
Yeah.
Now, my question is related to statements about a organization of or a configuration beyond the nation state, which is something that is very interesting to me. I remember hearing or reading somewhere that Lyndon LaRouche spoke about that. Do you have references to that speech or any kind of references to material? And two, what would it entail exactly? I mean, what or not? Well, not exactly, but in the specifics, like in general ideas. And three, how do we organize people, especially in the world's most advanced, you know, economically and scientifically advanced nations, notably the United States, Russia, China, India, and maybe put in a few European and Southwest Asian countries into that mix. What would be the best way to organize the world's people around that? And that's my question.
I don't know the exact form that it would take. I do think the fact that man is leaving the planet right now and is a direct confrontation of what we'll have to how we'll have to act differently in a new space, and we need to ensure that we do not take war into space. I think that the principles of Vernadsky are essential in this approach to a physical economic collaboration around material development, scientific development, cultural development. So yeah, I don't think that I could say in particular what form it would take. I just have a sense that that is the essential direction, that maybe others have more thoughts.
Well, I do recall LaRouche pointing to that to being an eventual future for mankind. But at this point, we're organized into nation states mainly because if you want to have a society that's organized for the benefit of the people, then the people have to participate in the deliberations that govern them. And that has to be done through a common language and a common culture. Now, I know there's a lot of cultural and language barriers that are being broken down as we progress, but I think it's going to be a few generations before you can really finalize that. And really the issue is, what are the principles upon which every group of nations can agree on? And what can they really actually agree on that's not going to be tolerated? The most important thing is, I would think, is to raise the material standards of living for everybody on the planet so that they can be part of this process. I think that has to be number one. Well, I'll just say that much.
Okay. Thank you. Let's it's getting late, but let's take one more. So Steve, go right ahead. Go ahead and unmute.
Okay. Okay. You know, I really liked how everything unfolded here tonight. Rachel and Bill. It was you know, we're not always especially in school and in culture, we're not introduced to a scientific discussion that is more like the dialogue. I think you brought out a real drama that is in human history that all too often we just you know, see movies of wars and, you know, just your hard political stuff. And so I wanted to just ask generally, just to discuss more of what we have to look forward to, because we brought up the classroom, what we have to do in the classroom to communicate these ideas in this kind of dramatic form, in art, in plastic art, in paintings, obviously in music, poetry. Maybe we need to have an opera on Einstein or something. But maybe if you could talk a little bit about how our challenge will be to communicate these and bring to life these scientific ideas of Vernadsky. A lot of ways you did, the way that Plato, the dramatic dialogues, you know, started science in this way.
If you recall the presentation that Richard and Laney gave on aesthetical education, this was covered by Friedrich Schiller, my other boy besides Leibniz. The whole subject of those essays is, how do we make mankind capable of self-government? Because to be man, you have to be free. You can't be compelled. Man must not must. On the other hand, to maintain the physical survival of the species, you can't have all these free people doing whatever the hell they want, regardless of the physical consequences, the physical economic consequences. That's why you have to have government. So, but how can you have a government that has the maximum freedom and the maximum benefit and maximum progress for the population? Well, what you have to do is you have to have better citizens. You have to have people whose inner impulses their drives for what they want individually are not in constant war with the requirements of physical necessity or the wants of others. In other words, you have to have people who not only are educated in terms of their so-called practical knowledge or ideas, but they have to have the emotional quality. You have to educate the emotions. The emotions, if the emotions are in harmony with the reason, then you don't have these conflicts. And Schiller identifies art as the means by which that's accomplished. I mean, there's much more to it, but one thing I would recommend, and this is an excellent piece. I guess I can put if I can do my computer stuff, I can put the resource in the chat. It's a speech that Helga LaRouche gave in 2003. It was entitled, "Overcoming Your Fears by Increasing Your Geistesmaßen." And I was going to have a lot to say about Geistesmaßen tonight, but the time, it just flew. Time flies when you're having fun.
Sunday.
So yeah, we can take it up some on Sunday. So this is a speech she gave in 2003, where she talks about this concept of Geistesmaßen from Herbart, one of Riemann's inspirations. And Riemann develops this idea, which he expresses in some of his philosophical writings, but also in the concept that he called Dirichlet's principle, which was applied to physical science. And it's the idea that LaRouche was referring to in that quote that Rachel began with, about how these students of classical Greek didn't know what they were doing because they hadn't re-experienced or replicated the thought process of that was expressed by the authors that they were reading. In other words, to create a new idea or generate a new thought mass or thought object, you have to recreate the idea. You have to go through the experience of discovery. And in the paper, Vernadsky and the Dirichlet principle, LaRouche says that that's the reason that he could completely see that Vernadsky's thinking was the same as his, because of the way Vernadsky developed his idea of the biosphere and the noosphere. Okay, so and Helga is saying, well, just like you go to the gym to strengthen your body, you've got to build up your mind. You have to strengthen your thought formation, and you have to train your emotions such that that's your joy, to develop that capacity. Now, I mean, that's the kind of culture that would correspond to this new security and development architecture.
Yeah.
I would just say also, study it yourself. There is a great pleasure in challenging yourself to master ideas. And as Bill mentioned, and this idea of rediscovery, everybody should rediscover Vernadsky for themselves and attempt to communicate it to others. But I think the great thing about Vernadsky is it does get any sort of axiomatic problems out of the way. You bring it up with someone on the left or someone on the right, and it gives them a way to start thinking, to get rid of those axioms. And it doesn't matter where anyone is on the spectrum, but suddenly, thinking in the way of Vernadsky, you've just got a completely different approach to economics in the universe and everything. So I think that probably is actually also why LaRouche said this should be, part of a global culture or a Eurasian culture. That's what I would say.
Thank you. Good. Well, I can pass on here. Adam, thanks you both for your responses. Also, Rachel and Bill. So let's do this now. Given the time, we're going to have to officially wrap up, but I know Bill is willing to stay on for overtime. So if you would like to continue freewheeling discussion with Bill, just stay on Zoom and we'll do that. But let me just ask Rachel and Bill if you have anything that you'd like to say, as at least for the YouTube version, as we bring that to a close. If you'd like to say anything in conclusion tonight.
Have fun.
Okay. All right.
Okay.
So in that case, yeah.
I just the speech by Helga. I just put it in the. I think I put it in the chat. Can you see it there? Hello, am I muted?
No, yeah, it's in the Zoom chat, and I'll put it in the YouTube chat.
I guess that's why in Germany they call a high school the gymnasium. Or maybe it's the other way around. I don't know.
Okay. All right. Well, Bill, I will turn things over to you. So just go ahead and unmute people. So Dave, if you're on, this is where we can wrap up our streaming, and Bill, just